find the value of C and construct the joint probability distribution table of X and Y. As we know, probability distribution table is equals probability distribution sums up to 1. So based on that, we construct a probability distribution table from function fxy is equals to C times S plus Y with X equal to 0, 1 and 2 and Y equals to 1, 2 and 3. From that, if we sum up all the 9 column that we get 27C, that is equals to 1. So from that, we can get the C equals to 1 over 27. For question 1b, we need to find the marginal distribution of X and Y. So as we know, the marginal distribution is the sum up of all fx. So we need to sum all the probability of X value. So from 6 over 27 plus 9 over 27 plus 12 over 27 is equals to 1. For Y value, for marginal distribution of Y, we need to sum up all the column that has the Y value, which is 6 over 27 plus 9 over 27 plus 12 over 27, which is equals to 1. For question 1c, we need to determine whether X and Y are independent. So to check if it's independent or not, the joint probability distribution must be equal to the marginal of fx and fy. To test this out, we take the value of x equals to 0 and y equals to 1. For the probability distribution of f0 and 1, we get 1 over 27, which is not equals to the probability, the sum of probability marginal of x equals to 0 and y equals to 1, which is 4 over 81. Hence, x and y are not independent. Calculate a conditional probability. We are looking for the probability that y is less than 3 and given that x is exactly 2. Using the conditional formula, we take the sum of probability where x equals to 2 and y is either 1 or 2, which is 7 over 27, and divided by the total marginal probability of x equals to 2, which is 12 over 27. This simplifies to a final answer of 7 over 12. For question 1e, we need to compute the variance of x and variance of y, and hence find the e for x squared plus 6y minus 2. For the first step is, we need to find the variance of x. To find the variance of x, we first need its expected value. We calculate ex by multiplying each value of x by its marginal probability fx. As shown, 0 times 6 over 27 plus 1 times 9 over 27 plus 2 over times 12 over 27 give us 11 over 9. We repeat this for the ex squared by squaring the x values first, which result in 19 over 9. To find the variance of x, we apply the variance formula, which is ex squared minus mean square. By taking our value of ex squared, which is 19 over 9, and subtracting the square of our mean, which is 11 over 9 times to the power of 2, we find that the variance of ex of vx is 50 over 81. We follow the exact same procedure for vy using its marginal probability. We find that ey is to be 20 over 9 and ey squared is 50 over 9. By applying the variance formula again, we find that the variance y is also 50 over 81. Having this value ready is essential for the final part of the question. Finally, we compute the expectation of the function e to the power of 4x squared plus 6y minus 2. Because expectation is a linear operator, we can break this into 3 parts. 4 times e x squared plus 6 times ey minus the constant e2. By substituting our value, 4 times 19 over 9 plus 6 times 20 over 9 minus 2, we arrive at the final answer of 178 over 9, which is approximately 19.78.
Part A. To find the value of k, we use the basic property of a probability density function, which is that the total probability must equal 1. So, we integrate the joint density function over the given range of x and y. First, we integrate with respect to y while treating x as a constant. Integrating 3x squared with respect to y gives 3x squared times y, and integrating xy with respect to y gives xy squared over 2. After substituting the limits from 0 to k, we simplify the expression and then integrate with respect to x. After solving the equation, we obtain a quadratic equation in k. Solving this equation gives k equals 2. Since k must be positive, we take k equals 2 as the final answer. Part B. Here we need to find marginal density of x and marginal density of y. To find marginal density of x, we need to integrate the joint density function with respect to y over its range. Here, x is treated as a constant. Notice that the 3x squared does not depend on the y, so integrating it simply multiplies it by the upper limit too. That is why the 3x squared becomes 6x squared. After integrating and simplifying, we obtain the marginal density function of x is 2x squared plus 2 over 3x. For marginal density of y, we integrate the joint density function with respect to x from 0 to 1. After integrating term by term and simplifying, the marginal density of y is 1 over 3 plus y over 6. Part C. To check whether x and y are independent, we compare the joint density function with the product of the marginal density functions. If x and y were independent, the joint density function would equal f of x times f of y. Since the product of the marginal densities does not equal the given joint density function, we conclude that x and y are not independent. Part D. We are given a linear combination of random variables. P equals to 6x minus 3y plus 4. Next, we need to find the mean and the variance of P. For mean, we need to use the linearity of expectation. E of P equals to 6e of x minus 3e of y plus 4. Using the marginal density functions, we calculate e of x and e of y and substitute them into the formula. The final value of the mean of P is 19 over 3. For the variance of P, we need to use the variance formula for linear combinations. Variance of P equals to 36 variance of x plus 9 variance of y minus 36 covariance between x and y. After calculating the variance of x, variance of y, and the covariance between x and y and substitute them into the formula, we obtain variance of P is equal to 46 over 9.
That concludes our presentation. We have ensured that our presentation is under 10 minutes. Thank you and have a great time.